Don't tell Ed I said this. The title chapter of the book, Death by Black Hole, comes from a section called, it's called When the Universe Turns Bad. All the ways the cosmos wants to kill us.
Yeah.
And there are too many people out there say, oh, we live in a beautiful universe that's just made for life and Earth is perfect. And it's like, no. First, Earth is trying to kill you with earthquakes, hurricanes, tornadoes, tsunamis, floods. The whole lot of ways the Earth wants to kill you, not to mention viruses and the like.
Yeah.
You get done with that, now that's Earth. Now the universe wants to kill you with asteroid impacts and, so let's be candid about that. And so there's a whole section that lists these ways. Mm-hmm. Some ways are more likely than others. Death by black hole, you're not likely to die that way. But if you had a choice, if I had a choice, I'd pick that way. Because it's, oh yeah.
Yeah?
Oh yeah. Oh yeah. Death by black. So what happened, because it's spectacular. If you had the choice of getting hit by a car, falling off a cliff, or falling into a black hole, I'm taking the black hole.
Okay, now why?
Oh, just because it's intriguing.
Okay.
It's a one-time experiment, obviously, because you're not coming back. Nor will you really get to tell anyone else about it. So it's for your own enlightenment in these last few moments of life. You have not fully expressed your power as a voter until you have a scientific literacy in topics that matter for future political issues. This requires a base level of science literacy that I don't think we've achieved yet.
What should be done about the fact that our kids lag woefully far behind children in other countries in the areas of physics and mathematics?
My first reply is, as a parent, get out of their way. When you're a kid, you're born a scientist. What does a scientist do? We look up and say, I wonder what that is. Let me go find out.
Right.
Let me poke it. Let me break it. Let me turn it around. This is what kids do. You can't let a kid alone for a minute without them laying waste to your house, okay? Because they're grabbing stuff off the shelves. And so what do? We prevent that. We prevent these depths of curiosity from revealing themselves, even within our own residences. And so I swore that when I had kids, and I do have kids, I got an 11-year-old and a 7, but when they were young, and still today, if they see something they want to experiment with, even if they might break it, I just let it go. Let the experiment run its course. Because therein is the soul of curiosity that leads to the kind of mind you would want as a scientist.
So you talk about events that can cause the end of the world. Does this knowledge keep you awake at night?
Yes. Yes. It might keep me awake in a different way than others. There are many people who, when faced with disaster, impending disaster, they say to themselves, okay, let me buy emergency food, let me find the shelter to go to, let me alert, okay. When you're trained as a scientist or an engineer, that's not the first thing you think of. First thing you think of is, how can I prevent the disaster?
Right.
Here comes the asteroid. You're going to run away from it, or you're going to say, how can I figure out how to deflect it? That's why you want scientists and engineers in your midst. Otherwise, you're just running away from every possible disaster that could affect life on Earth. And what kind of life is that? Enterprise that should be cherished as an activity of the free human mind, because it transforms who we are, how we live, and it gives us an understanding of our place in the universe.
What is the most astounding fact you can share with us about the universe?
The most astounding fact is life on Earth. The atoms that make up the human body are traceable to the crucibles that cooked in their core under extreme temperatures and pressures. These stars, the famous ones among them, went unstable in their later years. They collapsed and then exploded, across the galaxy. Guts made of nitrogen, oxygen, and all the fundamental ingredients of life itself. These ingredients become gases that condense, collapse, form the next generation of solar systems, stars with orbiting planets. And those planets now have the ingredients for life itself. So, sky. And I know that, yes, we are part of this universe. We are but perhaps more important than both of those things is that the universe. When I reflect on that fact, when I look up, many people feel small because they're small and the universe is big. They feel big because the atoms come from those stars.
That place in the universe you talk about, as you know, scares some people. Someone once told Sagan that they didn't like astronomy because it made them feel small and insignificant in comparison with the grandeur of the universe. It clearly didn't affect you that way.
Well, it depends on what your ego is going into the conversation. If you have no ego, if you just want to explore the world, look what happens. You learn, oh, the molecules and the atoms of those molecules in my body are traceable to stars across the galaxy that have lived their lives, manufactured these elements, exploded them into the universe, from which new generations of star systems were formed. So I look up at the night sky. I don't feel small. I feel large. I feel connected to the universe. It's not just we here on Earth, and that's there. We are one. And that link, for me, is one of the most profound discoveries of modern astrophysics. And if that should not make you feel small, that should make you feel large.
And talk with any scientist who's ever lived, who would it be and why?
Isaac Newton. Isaac Newton.
Why?
No question about it. Isaac Newton. The smartest person ever to walk the face of this earth. You read his writings. The man was connected to the universe in spooky ways. The most successful scientists in the history of the world are those who pose the right questions. If I asked you, at what temperature does the number 7 melt? What's the square root of a pork chop? These are meaningless questions. Maybe philosophers would run with them, but they're scientifically meaningless. Abandon them, go on to the next problem. Newton, his questions reached into the soul of the universe, and he pulled out insights and wisdom that transformed our understanding of our place in the cosmos. Mm-hmm. Somebody said, Ike, why is it that planets orbit in this shape you call ellipses rather than circles? Why that shape? And he says, I'll get back to you on that. I'll get back to you. Goes away for a few months, come back. Here's the answer. Here's the answer. Here's why gravity produces ellipses for orbits. The guy said, well, how did you figure that out? Well, I had to invent this new kind of mathematics to do it. He invented calculus. Most of us sweat through it for multiple years in school just to learn it. He invented it practically on a dare. He discovered the laws of motion, the laws of gravity, the laws of optics. Then he turned 26. Okay?
I'm with you.
And I own everything he's ever written, most of which written in his day. Mm-hmm. I commune through time as I read Isaac Newton, transporting me into a time and a place where people were just figuring out how this universe worked. And for me, that's thrilling and humbling.
Go think whatever you want. Go ahead. Think that there's one God, 2 gods, 10 gods, or no gods. That is what it means to live in a free country. The problem arises is if you have a religious philosophy that is not based in objective realities that you then want to put in the science classroom. Then I'm going to stand there and say, no, I'm not going to allow you in the science classroom. I'm not telling you what to think. I'm just telling you in the science class, you're not doing science. This is not science. Keep it out. There's all this talk about investing in medical breakthroughs, predominantly through the National Institute of Health. That's the primary sort of government agency for medical research. What I caution is, fine, we all want to live healthy. No, that's not even here to debate.
keep in mind that if you take a tour through a hospital and look at every machine with an on-off switch that is brought into the service of diagnosing the human condition, that machine is based on principles of physics discovered by a physicist in a machine designed by an engineer. Nowhere in that equation was there a medical doctor or a medical researcher. And so you can't just fund one branch of scientific inquiry. You have to fund them all. Because these advances, for example, the MRI, came from principles of physics discovered by a physicist who had no interest in medicine. That wasn't his point. That wasn't what drove him. Yet it has this marvelous application that we could diagnose or at least probe inside your body without cutting you open first. So the cross-pollination of disciplines is fundamental to truly revolutionary advances in our culture. And so you can't fund any one thing without the other, lest you believe you're right on top of a solution when in fact you're not.
Mystery of the universe. These mysteries, we're tackling these mysteries one by one. If you're going to stay religious at the end of the conversation, God has to be more to you than just where science has yet to tread. Reductionism is one of the words I swore I would never use in my entire life. Another word is epistemology. They're words that rage among philosophers when they talk, and I try to get as far away as I can from those words. There are too many syllables for me. You want to go away from sound bites, and I don't have a problem with sound bites. Can I tell you how I learned about sound bites, if I may? It was 1995. The first ever planet orbiting a star that was not the sun was just discovered. I had just joined the staff here at the American Museum of Natural History. I was a staff scientist. I was not director. Actually, at that point, I was interim director. The previous director had left. A new director had not yet been appointed. It was all the news. The news was hitting, and NBC sent a reporter to the Hayden Planetarium for a quote. Okay. So they didn't know me from anything. I'm just the director, so the interim director. So you get a quote from the man in charge. So that's what they did. So they said, well, how do we know this is a planet? And I gave my best professorial reply. Well, the Doppler shift, as it moves around the sun, the star, and it shifts, the waves get compressed and expand one and another, and you can calculate, there's a formula, you calculate that, you get this shifting of the spectrum of the star, you infer the presence of a mass, and you get a planet. Okay? And I described the fact that as the planet moves around the sun, its host star, the star moves in response to that. And it's that movement of the sun that we measure. Okay? So I go running home, put on the TV, and all they had was me doing this. No Doppler shift, no. And I thought to myself, at that moment, even though they're interviewing me in my place, it's actually for them, in their place. And in their place, sound bites rule. They can compress the World War III into a 4-minute story. Everything is a sound bite. So I said, rather than have them sound bite me, why don't I hand them sound bites? They can't edit that. They got to use them as sound bites. So I stood there in front of a mirror and I just barked out Saturn, rings, black hole, Big Bang, Alpha Centauri, Earth's core, comets. And for every one of those words, I said, what are 3 sentences I can put together that are informative, make you smile, and are so tasty you might want to tell someone else? There is the anatomy of a sound bite. And don't think that sound bites aren't useful if they don't contain a curriculum. A soundbite is useful because it triggers interest in someone who then goes and then puts in the effort to learn more. And that's what all a museum can really be. A person spends, 6 hours a day times, 10 months a year times 12 years in school, but they spend 3 hours in a museum? And you want them to learn something you could test them on when they get out? No. I mean, you could try, but I think it's unrealistic. Take the moment to stimulate interest. And upon doing so, you have set a learning path into motion that becomes self-driven because that soundbite was so tasty. Why do you think we call them bites? So, and that's kind of what Twitter is. It's almost like haiku, actually. It's like the fewest words to convey the most. And it feels like when I compose a tweet, I feel like, was it Leonardo? Who's the guy who said when they're making a sculpture, Michelangelo. It was Michelangelo says, I just cut away everything that isn't the man or the woman. And then that's what's left, is the woman. Now you can do that with Michelangelo. You can know what piece would not be the man. But you trim, you carve the words such that all that's left is the most important concept communicated in the simplest, most direct way. And that does not mean using big words. So I don't have a problem with that. And ever since that interview in 1995, that's what I've been doing. And I give them a soundbite, and I go back and sit down, and then they come back every time. So they like it. People say, "Oh, how do you get on the news so often?" I'm not looking to get on the news. I'm stay home with my kids. I don't need to go out and be on anybody's newscast. But they remember the last soundbite I gave them. I'm okay with that.
What these questions
Keep them damn things to yourself.
All right. Our first query comes from Mark Miller from Halifax, Nova Scotia. Mm-hmm. This is actually a two-parter. Mark wants to know, what would the world be like without skepticism, in your opinion? And then the second part of the two-parter is from Adam Rammer from Toronto, Ontario. And Adam wants to know, how do you know if your standard of proof is too high? How do you know if you're not being too skeptical? So what is the world without skepticism, and what is the world with too much skepticism?
Oh, that's good. So world without skepticism, we've experienced that in the history of civilization. It's called the Dark Ages. All right? Yes.
That is scary.
It's the Dark Ages, where no one is curious about how something works. They believe they have all the answers, and those answers are wrong. And so society does not function in any way that is enlightened or leads to solutions to the problems that confront people. And so they live in misery, affected by problems that they cannot solve and will never solve, which makes the afterlife all that much more attractive.
True. Okay, so how about too much skepticism?
It is possible to be too skeptical. And here's a way to think about that. If you perform an experiment, you get a result, and you say, well, maybe if I perform that same experiment tomorrow, I'll get a different result. So then you perform it, but you get the same result. And to a scientist in the groove, you do this enough times, you say, I'm done, and I'm on to the next problem. Mm-hmm. But you can have a level of skepticism where you say, maybe if I did it in the next building, I'll get a different result. Let me try that. Maybe if I do it in a garage, and maybe if I did it you could stay with it, okay. But there's a point where you say, look, you got the right answer here, all right? Move on.
Enough is enough.
Enough is enough. And you'll spend the rest of your life demonstrating something that you already showed was true in the first few experiments. Now, in all fairness, you could be biased in every one of those experiments. You got to get somebody else to do it.
and somebody else who wants to prove you wrong, and then they end up showing that you're right. When that happens enough times, we're done. We're done. You didn't describe science this year, right there. You described a drug problem. And what is it? Isn't there? There's a famous definition of insanity: is doing the same thing over and over again, expecting a different result. Is that a definition of insanity?
I think it works.
Does it work?
First of all, should we be worried, or is this just a complete coincidence that these two things happened?
Hell yes. Is that allowed? First, it was a coincidence that they happened on the same day. Just to clarify for those who might not have remembered, early morning there was an asteroid that entered Earth's atmosphere over the Urals in Russia and exploded in midair about 20 miles up. And it shattered windows. The blast was brighter than multiple suns. In fact, subsequent measurements of how much energy it contained rivaled 30 times that of the Hiroshima bomb. And the reason why everything wasn't just pancake flattened from it was because it exploded so high up in the atmosphere. And so all that was left was the energy that remained after it diluted into the space in which it exploded. Later in the day, there was another asteroid that had a close approach, which we've known for about a year. Using the laws of physics and orbital trajectories, you can say exactly where it's going to come. That was of interest because it not only came between us and the moon, it not only came there, we've tracked many that have done that. This one came inside of our technological space. It came closer than our orbiting communication satellites. And so that one you take note of. And that asteroid is about half the size of a football field. The one that hit and exploded over Russia, that is about a third that size. We have no capacity to protect Earth from things that small.
So what should we be doing? I mean, how scared should we be that the laws of math? Well, at some point, the probability is one of these things will hit.
Okay, fortunately, the larger asteroids, the ones that could disrupt civilization, disrupt the energy grid, the transportation grid, the emergency services response setups.
Or just plain kill us.
Well, yeah, they'll all kill somebody who's right below it. What you care about, yes, of course we care about that. But globally, what deeply concerns you is the asteroid strong enough so you have to restart civilization? And then at another level, you risk extinction. Fortunately, those are large. And we have a plan in place, NASA has a plan in place to detect and map and track every single asteroid that's large enough to disrupt civilization. The one that exploded over Russia was not large enough to disrupt civilization. And so they're dangerous and they'll hurt and they can kill. But the fact that we can't track them is not as bad as not being able to track the big ones that could really destroy us. So once you know where they are, your next question would be, perhaps, do we have a plan to do something about it? And the answer is no. It's all just on paper how to do it.
What would be the plan? Would it be some kind of military?
Yeah.
You shoot a missile to shatter it in outer space?
Yeah, that's the macho solution. You pull one of your missiles out of the silo that have been sitting there doing nothing since the Cold War, and you blow the sucker out of the sky. The problem is, I mean, here in America, we're really good at blowing stuff up, and less good at knowing where the pieces land. You know, so
that's a metaphor for America.
I was sticking it to asteroids. You take that where you want. People who have studied the problem generally, and I'm in this camp, see that a deflection scenario is more sound and more controllable. So if this is the asteroid and it's sort of headed towards us, you send up one way is you send up a spaceship, and they'll both feel each other, and the spaceship hovers, and they'll both feel each other's gravity, and they want to sort of drift towards one another. But you don't let that happen. You set off little retro rockets that prevent it. And the act of doing so slowly tugs the asteroid into a new orbit.
Because the spaceship has a kind of gravitational pull?
Exactly. They want to draw towards each other. But if you don't let that happen and you constantly yank the spaceship away ever so slightly, then the asteroid will chase the spaceship ever so slightly. And that's all you need if you get it early enough, because the tiniest change in your orbit early can completely avoid the target. Now, of course, it's there to harm you another day. But if you get really good at this, then you can have a protection system for the Earth that will prevent humans from going extinct.
which seems a laudable goal.
Yeah, I think that's a...
Now, is it fair to say that we don't need any innovation in physics or even in engineering? We know how to do this. The question is the will and the resources to implement a plan like
Yeah, I mean, we use ordinary physics to know how to make this work. And physics and engineering, of course, because you've got to make the hardware to enable it. And the price is not even all that expensive given other activities that humans have undertaken. The problem is the asteroid that we might find that will one day hit us, and you want to get it early, all right? When do we start concerning ourselves with a budget to handle it? If it's going to come in 100 years, what do you say? Let our descendants worry about that in their Congress. You know, 88% of Congress faces re-election every 2 years. So how, you know, it's Senate and House, of course. And so that's not a long enough time scale to match the time scales that matter for our survival. So plus, if an asteroid is going to strike somewhere else in the world, is it NASA that's going to take care of that? So what you really want, I think, is a world organization. Maybe every country chips in proportion to their GDP, something sensible like that. And then there's a pot of money. And whoever has the spacefaring resources at the time it's necessary, spacefaring know-how, would then tap into that money, and then you save the Earth. And I think that's a reasonable path.
All right, so we have your next job all mapped out for you. Space Czar for the world. Neil deGrasse Tyson. Pleasure to have you
Thanks
on.
for having me.
Yeah, but you know what? I totally agree with you, but here's a funny story that happened to me 2 hours before I came here on the way. I get into the taxi cab, and the driver asks me where to, and I give him the address, and he's asking me very nicely, what are you doing there? Who are you going to see? And I tell him, I'm going to see Dr. Michio Kaku. So he asked me, okay, who is Dr. Kaku? And I tell him, well, he's one of the founders of string theory, string field theory. And then he asked me, what is this? I say, well, this has to do with sort of the beginning of the universe, the Big Bang theory, the multiverses, etc. And to that, his response was like, some people are crazy. So how do you feel about that kind of attitude, which seems to be kind of surprisingly prevalent in a large part of our population today in a 21st century advanced world like New York?
I think he's right. There are crazy people out there because the universe is crazy. If form and content, if appearance and essence were the same thing, there'd be no necessity for science. The whole purpose of science is to see the difference between appearance and essence. In other words, the universe is crazy. In fact, it is crazier than we can even imagine. Who would have thought we would have quantum mechanics? Who would have thought we could have dead cats and live cats existing simultaneously? Who would have thought that you could be in many places at the same time? That's called craziness. It's also called modern physics.
And I love it, by the way.